is Amir Herzberg of University of Connecticut. And he is going to present his work called the DISCO, Sidestepping RPKI's Development Barriers. So please join me to welcome Amir.
Okay, thank you. He's actually joint work, as you can see, with many people. You have all the names and use the time to go forward, and you have the name. So the work is about securing BGP, the BGP protocol. And just in case you're not all familiar with it, I'll very, very briefly introduce this very important protocol, okay? So the internet is composed of many different network of different organizations. We refer to these networks as autonomous systems or domains sometimes or ISPs, but in this talk and usually in the BGP literature we refer to them as autonomous systems or ASS. And the communication is separate between the communication within such an autonomous system and between two different autonomous systems. And to select the route, which autonomous systems would we select to reach from our source to destination, we use an inter-AS routing protocol, which is called BGP. That's just a single protocol on the internet. And you could view it as like the glue of the internet, which is allowing us to communicate from anywhere to anywhere. So it's very, very important. For example, in these pictures that we see here, you see AS, I don't know if we have a marker here. I didn't bring any. Okay, we can see just three ASs in this simple example, AS2, 10, and 3. And as you see, AS10 is sending an announcement about some IP prefix, some block of IP addresses. This specific block is the block 1, 2, and then any 16 additional bits. So it's 1, 2, 16. And the path is just, I'm AS10, so here's, actually it's written 100 to there, that's a typo, and this is the destination, okay? And then sending to AS2, AS2 learns this, and okay, I can now route to this prefix, to these addresses in this prefix, and then it sends it forward to the neighbor, to AS3 in this simple example. So it says, okay, this is the prefix, same prefix, and now the path is, you can send through me, and then to AS10. Okay, so this is the path now, it contains 10 and 2, okay? And to reach this prefix, you can simply send via me. Okay, and that will be the path. So that's the standard thing, that's how BGP works, that's how the internet works. And then the traffic, if you have some traffic to send to that destination, you select among these announcements you received for that prefix, and you just select one of them. There are some preference, of course, like you would normally select the shortest path, smaller number of ASs, and some other considerations, and not get into this. And then you just send the packets in that direction, and they will reach the destination. That, I think, is fairly simple. Protocol is not so simple, but I think I've simplified it sufficiently for our purposes. Okay? So, unfortunately, BGP does not have any built-in security mechanism. So, and in fact, it has a very long history of problems, attacks, and also misconfigurations, and not only intentional attacks. And in particular, these include manipulations of the routes, where instead of sending the correct route, you're sending something which is incorrect. Like you did not receive, maybe you don't own the prefix, but you still announce as if your AS has this prefix information. This is called usually prefix hijack, and that is the most common threat on internet routing today. This very simple thing, that just an AS claims to be the owner of some prefix that it was not assigned to him. IP prefixes, IP addresses today are very expensive, so this is just stealing them is already a serious thing, okay? But of course, it's used for much more severe things than just, using an IP address that was not assigned to you because you save money. It's used for many, many attacks. I will not have time to go over that. Anybody interested, I'll be happy to tell later. So that's indeed a very common thing. There are other ways of manipulating the route. You can claim to be connected to the origin. All kinds of things you can do. There are also route leaks where you receive an announcement, but you are kind of not expected to announce it to the internet, like you are a consumer AS, some small company or university or whatever, and you get this announcement from your provider, and then you go ahead and you announce it to a different provider. So yes, it's legal to do that. It's like you're not breaking any law, or well, it's not really law, but you're allowed to do that, BGP, if you ask BGP, because you receive the announcement, you are allowed to send it to others, but it doesn't make any sense. So usually these route leaks are just due to a mistake. So these kind of problems are very common in BGP, both these route leaks and these hijacks and some other manipulations, route manipulations. Here is a simple example of this prefix hijack. Prefix hijacks, by the way, many times they are intentional and malicious. Route hijacks, route leakage are usually benign. We focus on the prefix hijacks. And this is a simple example. You see I've added just one more AS, this bad AS 666. And that AS is announcing the same prefix, although it was not assigned this block of IP addresses. And now what happens to poor AS3 when it wants to send the traffic to this prefix? Well, it will pick, let's say, because it is shorter, it will pick this announcement, and it will send to the attacker the traffic. Very bad, okay? So we need, obviously, to deal with that very serious threat. However, like I mentioned, BGP does not have security mechanisms and all these attacks, so how do we defend against this kind of phenomena? There are defenses. I will not have time to really discuss them, but the current main defenses are very ad hoc, proprietary solutions, very expensive, and also very not weak, not really providing serious security. So you pay a lot of money, but actually you get very weak security from what is available. It's a well-known problem for many, many years, more than 20 years. Huge problem that has not been solved yet. I would be happy to tell you afterwards how I got into all this thing. I've been working on this for quite a few years, and we have very nice progress. This work is just one part of that general direction that we are working on. Okay, so there is also effort to protect against in the IETF, in the Internet Standardization Body, and that is composed of two main standards. The first is BGP-sec, which was published in 2017. And it's a very ambitious standard. It is trying to prevent all of these route manipulation attacks. So if you want to change, you got a route and you change it in some way, non-legitimate way, or you don't get a route, but you just invent as if you got it, all of that should be prevented. Not route leakage. That is because, as I said, route leakage is like you are following the rules. It just kind of not makes sense. So we are talking, BGP-sec is still focused on kind of breaking the BGP rules, and it is supposed to prevent all of that. So that will be great. Unfortunately, deployment of BGP-sec, not have time to go into the reasons, but it is very hard, which is putting it mildly. It's actually very unlikely to ever happen. I am of the many people in the area which believe this is unlikely to happen. Again, we don't have time, but also, BGP-sec is actually building on the other standards that I mentioned, which is called RPKI. So we will focus on RPKI. And RPKI, also published in 2012 already, is focused on this specific threat of prefix hijacking. So it's much more limited in its scope. On the other hand, remember that prefix hijacking is definitely currently the most common problem, especially for attacks on the BGP protocol. So it is important. Okay, and we'll focus on that. What is this RPKI? So here's RPKI in a minute, right? So it stands for Routing Public Key Infrastructure. For some reason, by the way, the projector is killing all of the top lines. So you're seeing the foils except for the titles, right? But that's okay. You'll get the foils later if you want to see the titles, okay? So the title says RPKI is Routing Public Key Infrastructure, okay? And it is binding an IP prefix like this 1216 that we saw before to, I refer to it as PI, that's the notation for the prefix, to some public key, PK, okay? And that is the number one thing it does, which we call a routing certificate. So it's just like a regular certificate, but here we are not binding together a name and a public key, for instance, a domain name or username. We are binding together this IP prefix to the owner public key, to the public, right? And then there is another kind of signed statement used in addition to the certificate, which is called route origin authorization, or ROA, which is binding the prefix to the origin. So it's saying, okay, now that I own this prefix, you see this routing certificate, I own this prefix with this public key, I'm signing that you can announce the following AS is allowed to announce this prefix. And that is essentially what it is, right? And that's how you can define who is allowed to announce your prefixes, okay? And this ROA has some parameter called max length, telling how can you announce a sub-prefix of that particular prefix? How long could it be? How many bits? This is important because in IP protocol, if you announce a sub-prefix, then routing of data will always go to the most specific, the longest sub-prefix, okay? In any case, the ROA are signed by the public key, and they are distributed by these RPKI mechanisms. And the routers or ASs are supposed to run a system called ROV, route origin validation, which is looking at this routing messages and comparing them to these known ROAs, which are validly signed by certificates. And so it will be deployed by BGP router and will hopefully discard all of the invalid announcements. Okay. Now, how much is it really in use? So there are some of the prefix origin pairs which are announced, signed by these ROAs. About 18.5% of the announcement are actually valid in that sense. A bit less than 1% are invalid. So they are, you have a BGP announcement, they are not, most probably they are not actually hijacks, but somehow they could still conflict with these ROAs, so they look like a hijack. You would actually discard them, which is a big problem. And of course, there are many others which simply don't have any ROA, right? The concern is exactly one big concern. I guess there are two concerns. We want it to be deployed more, and we are concerned that if we filter based on these invalids, then sometimes we'll do a mistake and we'll drop valid announcements. That's a big concern. Another concern is that the security benefits are actually a bit limited of this. I will not get into this, but okay, maybe I'll just mention briefly that prefix hijacking is the most common problem, but there is a sub-version of prefix hijacking which is also pretty common, which is sub-prefix hijacking, in which you hijack a sub-prefix, and due to this issue of that IP prefers always the most specific announcement, then sub-prefix hijacking can be extremely effective. And unfortunately, for reasons that, again, I can cover after the talk, it's not so much related to this particular presentation, then actually ROV is not very effective against, not effective at all against sub-prefix hijacking, unfortunately. So that's actually a bit of a problem. In any case, maybe because of these limited security benefits, especially for initial adoption, maybe because of, more likely because of these concerns and other concerns, adoption is very slow, especially of this ROV. Adoption is slow. Okay. So just a bit about related work. So there have been a lot of related work trying to understand this ecosystem, this deployment, and how can we get this thing going, or is it going, and so on. These are just some of the works in this area. And also, there have been several works on trying to analyze security concerns about RPKI and to improve it in different ways. So again, I will not go over this, but there's been a work in this. We are doing something a bit different, which is also related to deployment. And that is, we are presenting a way to automate the issuing of the routing certification instead of the current process, which is completely based on documentation, manual process, and so on. The goal is to have a process which will be easier to issue these routing certificates and ROAs, and also avoid these many errors, which is maybe our biggest concern. Okay. So, so currently we have this large space for errors. We want to avoid that room for errors and to have both the routing certificates and the ROAs to be correct and issued in an automated way. Okay. So current system to issue the router certificate, you need to go to the organizations which issued you the IP address space. They need to look all kind of old documents and so on. It's a very manual process, very error-prone process. And an error will have legal implications, so you can understand that lawyers are involved, which you all know what it means, right? And on the other hand, the feedback to the operator on error is not actually very available, so that you can make an error, it can make a huge implication, you will not find it in time, you will not be aware of it. It's a big problem, right? So people are many times hesitant about doing that, okay? And the ROAs also, which they are supposed to be issued essentially manually by the network operator, which takes now a lot of responsibility. If he's doing a mistake, he may be fired, you know, but so they are not very excited about doing stuff like that. And there is, again, a large room for error, also because of some problems in the specification, which make people, many times, make errors related to this max length and not get into a specific, but it's actually pretty common. And again, no validation, no immediate feedback if you make an error. So I view it like the waltz dancing, which is very beautiful and great if you know how to do it, but few know how to do it. I mean, I don't know how many of you know how to do it. I definitely don't, okay? So I don't do waltz. On the other hand, I don't know if you have seen some of the videos in the internet of the dancing cryptographer. Did you try? Did you see them? No? So please, after this talk, go in the internet and see the dancing cryptographer. He's a friend of mine, Ivo Desmet, very good cryptographer, yes, and he's also a great dancer, okay? So he definitely does disco. Maybe he knows waltz. Okay, so we will want to do something like this disco, which is easier, more freestyle, more foolproof, okay? That's what we'll present. Okay, so what is this disco? Disco stands for Decentralized Infrastructure for, well, I don't remember. It's not me who invented this crazy acronym. I just invented this excuse for the name, but I didn't invent it, okay? So you have to see the title for this one. I really don't remember it by heart, okay? So it is an automated mechanism both to make these things easy and to reduce the errors, to ease adoption, okay? And here we see this diagram here, which of course I don't have a pointer, so it's a bit hard for me to, and there's also not a mouse here, so I cannot point in any way to it. So you have to see this picture here. So you see in the picture, we see some networks that is trying to get its IP address certified and to have ROAs issued and so on. The first thing they need to do is to prove their ownership of the IP space, of the address block they have. And what we do, we don't look by papers. We look at about who is actually de facto owning the IP space. So if you're right now fighting with somebody who's trying to steal your IP address, that may not be possible for you to claim ownership over the IP address. But usually, these stealing of IP spaces are very short-lived, almost always. So most of the prefixes at any given time, almost all of them, are not being under attack. So let's assume we have a prefix which is not currently under attack. What can you do? So you are adding your public key essentially to the BGP announcement. So when you announce, okay, I am the following AS, I'm announcing this prefix, you also put public key over there. And this public key goes to indirectly, because we are collecting from many vantage points. There are many vantage points which you can get all the BGP announcements they have received, okay? And we have these machines which we call the registrars, which go to this vantage point, download the announcement, and they can see the public key. And now they check, do we get the same public key from all different vantage points, from many, many different vantage points? Do I get the same public key? If I get the same public key from almost all, I'll talk about the numbers quickly later. But essentially, the basic is if I get the same public key from almost everywhere, okay, that's good enough for me as one of the registrars. Now, if each of these registers, we don't want to trust one registrar, so if each of these registrars will have a share of a distributed threshold public key, and then they do a threshold signature, just one share of the signature. We take all of the signatures together. If they are over some threshold, depending on your parameters of the public key, over some threshold together, we get a certified public key. So we get this routing certificate. in this secure way. And then they are put in a repository, which is actually similar to the regular RPKI. Everybody can download them, okay? So we have these two phases here. The register agents, as you can see in this picture, they validate that they got the same public key from all over. And then if everything's okay, they certify, they send to the repository, some details later. And therefore, the DISCO's routing certificate will essentially complement the RPKI routing certificates. What do you do if you have a conflict between the two? That we didn't define, because that's actually the different trade-offs. So that's a hard decision, so we didn't make that decision. But in any case, it gives you different bit benefits by doing that. Okay. Can we actually do it? Can we put the public key in this BGP announcement? They were never designed to carry public keys. So it turns out in this BGP, like many standards, there are all kind of optional fields and so on. And one of them is called the optional transitive attribute, which the standard specifies that you can use, and then an AS receiving it will simply carry it forward in the BGP announcements. That's what the RFC says, the standard, but is it really done? Well, you know, in the internet, standards are not really enforced, right? So many times standard says one thing, it's not exactly happening. So we decided to do an experiment. The experiment said essentially it's relayed by almost all ASs, not all of them, okay? And what? Oh, but I'll get into these details yet quickly. And registrars valid the public key received from everybody. It could be from the same AS or different ASs, because we could have some prefixes which are announced from multiple places, what is called anycast. But as long as the public key will be the same, we are still completely okay. So it's not supporting also these kind of multicast ASs. So it actually, this is turned out to work for 97% of the prefixes, most of the internet. There are some prefixes which is not relevant for different reasons. In particular, if they are not announced, definitely does not work, right? And some multi-home, actually it could work for multi-home as well, but we just didn't do the experiment, so we cannot for sure know. But it should work for multi-home too. So now we are just signing them. As I said, we are using threshold signature, so we don't need to trust any single registrar. They're using each of them has a share of the group threshold key, using the share, doing the partial signature, and then sending to the repositories. The repositories combine this partial signature, and we get the certified public key. We are all happy. So we have this resiliency and security by using redundancy of the different paths, by using the redundancy of the registries, and of course of the repositories too. The repositories redundancy is just to make it available, right? Because the repositories cannot cheat. It's all signed, but of course they can make it unavailable. Okay, so that's what we have. And then we also support the ROA mechanism, this issuing of saying this prefix is announced by this AS. Once we have the key, the public key certified, we can just sign the ROA automatically. And actually, that's another thing we are doing, which is not in classical RPKI. Our software is automatically identifying when you are issuing, when you are announcing some prefix, and automatically we create this ROA. So we don't depend on the operator. It also means that we deal with this complexity, which I didn't really explain about the max length, but there is some tricky complexity, again, tell you later if you want, and we actually deal with it automatically in the most efficient way. We do it for all sub-prefixes. If it's good to do it, we do it. But for all sub-prefixes, we don't open to some attacks, which you can do if, like many people, you don't do it for all sub-prefixes. Okay, in any case, the announcement is done of the ROA can be done automatically. The signature and the announcement can be done in an automated way. That's actually the default for our system. But if you want to keep your private key in a separate storage, you can also do it in a kind of semi-automated way. That's fine too. Okay. So does it actually work? As I said, we did some experiments on the internet to see if actually the public key would reach everybody. And we found that it does work. We use a specific transitive attribute which is designed for testing and development, okay? So it is designed for all kinds of test and experiment and so on. So that, well, you see in a moment why I mentioned this. Okay, I focus so much on it. And as you can see, most of the announcements actually received with this prefix, like 97% receive with only one origin, so that should work. And then we announced it on the internet. We did it twice. Both times had some problems, okay? The problems were due to some old routers, which not just old, but not patched, okay? These are software routers, which have a known bug, and the bug says that they don't support well this transitive attribute, but not just not support, they actually crash. And when we have announced this to the vendors, and the vendor actually released a patch and so on, and I think the patch was already existing before, actually, and just they told their customers, look, you should install this patch and so on. And then we said, okay, we'll do the experiment again. And then there were fewer people who crashed. So you see this graph, the blue line is the first time we did the experiment. And it has two peaks. The first peak is not related to us. It has nothing to do with us. We didn't begin the experiment in the first peak. But the second peak is actually due to this crashing of some routers. Second time is this orange line. You see the damage was much less. When I said damage, this is all kind of BGP announcements which were caused by this crashing and stuff. So in the second time, the damage was much less, but still there was damage. And maybe the bigger damage is that we got some very kind of threatening letters from one operator. Just one person who sent us really threatening letters. But don't worry, because the guy got a lot on his head from the Nanog communities. They actually said, you should have installed the patch and not complained. And we have, of course, told everybody in advance about the experiment and so on. So, okay. So it looks like it is possible to send this. We measured how many ASS drop the announcement when they get it with this extra attribute. Allowed by the standard, but they don't support and they drop the announcement, or they just drop this extra attribute, less than 1%, so it's really not a major problem for this distribution. I mentioned this unpatched few buggy routers. So can we do this certification? So we also did simulation with the BGP topology and checking reachability for all of these vantage points. The result was that we get it very well. I'll skip because we are running out of time. So it appears usable. And to summarize, conclusion is adoption of RPKI is really critical, is challenging. Automation and validation can help, and this DISCO may help also. But there are some costs involved in that. Many these people who already installed the prefixes maybe make it even harder to get the prefixes away from them a bit. Not much. Maybe it's not even needed. I'm not 100% sure that this specific paper or this specific idea is indeed so much needed. I just began this work long time ago when it was still less clear. This particular aspect of my research, I'm not 100% sure that we will really need it because adoption is proceeding. But there are other things that can help too, like improving security benefits of RPKI and improving the incentives. So, okay, thank you very much.
So we have time for one question.
Oh.
Yeah. Actually, I have a question. I also have a question, but I...
Well, anybody who has questions and we'll run out of time, please come talk to me later. I love this subject.
Just to make sure I was following you, for the partial signing, each registrar partially signs the same RC?
Of course. Yes.
Okay.
Yeah, that's how usually threshold signatures work. So this is just standard use of threshold signatures.
Okay. Thanks.
Yeah.
And so please, let's thank our speaker.
Okay.
Thank you so much.
Thank you.